Somewhere in the constellation Draco, two objects are orbiting each other every 57 minutes. They're not stars. They never had enough mass to ignite. But one is stealing matter from the other, and if it takes enough, a failed star could become real. You're listening to Stardrift FM. Tonight, a rover on Mars just found a river delta buried 35 meters underground, older than anything we've seen on the surface. Two brown dwarfs locked in a 57-minute embrace. An interstellar comet loaded with alien methanol. A planet made of cotton candy that even the James Webb can't see through. SpaceX fires up Raptor 3 for the first time. And a Russian cargo ship launches from a pad that wasn't supposed to be ready for another 2 years. Grab your coffee. Let's get into it. NASA's Perseverance rover has been driving around Jezero Crater for 5 years now. We chose that landing site because you can see a river delta from orbit, a fan of ancient sediment where water once flowed into a lake. That delta is about 3.5 billion years old, and it's sitting on top of something much older. A ground-penetrating radar instrument called RIMFAX has been pinging radio waves into the Martian soil every 10 centimeters along the rover's path. Normally, it sees about 15 meters down, but in a stretch of rock called the margin unit, the material was so transparent to radar that the signal went through. Twice as deep as anything before, 35 meters, the height of a 12-story building. And down there, they found clinoforms, sloping sediment layers that only form when a river dumps material into a standing body of water. A second delta buried beneath the one we came for, 3.7 to 4.2 billion years old, late Noachian era. That's hundreds of millions of years older than the visible delta above it. Lead author Emily Cardarelli from UCLA. This instrument allows us to actually see structures beneath the ground of another planet. And here's the thing. On Earth, rocks from this era have been heated, crushed, and recycled by plate tectonics. Mars has none of that. These 4-billion-year-old layers are frozen in time. If anything was living in that water, Mars remembers what Earth forgot. Cardarelli says they have 40 kilometers of radar data with more papers coming. The delta beneath the delta was just the first page. A brown dwarf is what happens when a cloud of gas collapses, but doesn't collect enough mass to start hydrogen fusion. Too big to be a planet, too small to be a star, they just glow, slowly cooling over billions of years. Failed stars? Our team at Caltech just found a pair of them, ZTF J1239+8347, locked in a 57-minute orbit. The entire system fits inside the distance between Earth and the Moon, and one is stealing mass from the other. Matter is flowing from the less dense brown dwarf to the denser one through a gravitational nozzle, slamming into the surface at nearly 9,000 Kelvin, hotter than the surface of the sun. The impact creates a glowing hot spot that makes the system flash more than 6 times brighter as it rotates into view. Here's the question that makes this extraordinary: the hydrogen fusion threshold, the line between failed star and real star, is about 80 Jupiter masses. The receiving brown dwarf is already between 60 and 80. If it gains enough mass, it could cross the line and ignite. Lead author Samuel Whitebook, The Failed Stars Get a Second Chance. His colleague Tom Prince. We've told some of our colleagues about them, and they didn't believe such a thing exists. And because the system is faint magnitude 20 and relatively close, there are almost certainly many more out there, hiding in the dark. 3i Tellus is only the third interstellar object humanity has ever detected. A comet from another star system discovered by the Atlas survey in Chile last July, moving at 58 kilometers per second, the fastest interstellar visitor on record. On March 16th, it made its closest approach to Jupiter, 53.6 million kilometers, right at the edge of Jupiter's Hill sphere where Jupiter's gravity dominates over the Sun's. Tidal stress could trigger fresh outbursts from the nucleus or even minor fragmentation. But the bigger discovery came from ALMA, the Atacama Large Millimeter Array. Astronomers pointed it at 3i ATLS last fall and found the comet is soaked in methanol. The methanol to hydrogen cyanide ratio is 70 to 124 times higher than what we see in comets from our own solar system. Nathan Roth, who led the study, observing 3I ATLS is like taking a fingerprint from another solar system. That fingerprint tells us the comet formed in a colder, chemically different environment than anything in our neighborhood. A message in a bottle, written billions of years ago in another star's protoplanetary disk and delivered to us by chance. 3 visitors from 3 different stars, each one completely different. And with the Vera Rubin Observatory coming online, we're about to start catching dozens more. 2,600 light-years away, there's a star called Kepler 51 with 3 planets that shouldn't exist. They're nearly the size of Saturn, but weigh only a few times more than Earth. Their density, 0.038 grams per cubic centimeter. That's the density of cotton candy. Scientists call them super puffs, and Kepler 51d is the puffiest of the 3. JWST pointed its NIRSpec instrument at the planet last year, covering wavelengths from 0.6 to 5.3 micrometers, the widest infrared window ever used on this kind of observation. They expected to finally see water vapor, methane, carbon dioxide, the chemical fingerprints hiding behind the haze that blocked Hubble. Instead, nothing. A perfectly smooth, featureless slope. No molecular features at all. Even the most powerful space telescope ever built cannot see through this planet's atmosphere. The culprit is a photochemical haze layer sitting at the very top of the atmosphere, so high and so thick that it absorbs everything before it reaches the layers underneath. Lead author Jessica Livy Roberts. The haze looks very similar to what we see on Titan, but at a much larger scale. Potentially as thick as the radius of Earth itself. 3 superpuffs in one system. Densities that challenge how we think gas giants form, and an atmosphere that even Webb can't crack. Some planets just don't want to be understood. On March 16, SpaceX lit up a Starship B3 Super Heavy booster for the first time. Booster 19 fired 10 of its 33 Raptor 3 engines on the brand new Pad 2 at Starbase. The burn lasted about 1 second before a groundside equipment issue cut it short. But that 1 second was enough. 3 firsts in a single moment. First V3 booster firing, first multi-engine test of Raptor 3. And the first operational use of Pad 2, SpaceX's second launch site at Boca Chica, built from the ground up for V3 vehicles. Raptor 3 is the reason this matters. It produces 280 tons of thrust, 22% more than Raptor 2, while weighing less. The entire external heat shield is gone. Plumbing that used to hang outside the engine is now routed internally. Advanced 3D metal printing replaced dozens of bolted joints, roughly a quarter the cost of Raptor 1. And the vehicle it powers, Starship V3, can put over 100 tons into low Earth orbit. Reusable. That's 3 times what V2 could do, more than Saturn V. SpaceX says the full 33-engine static fire comes next, then Flight 12 in April. 11 Starship flights so far, 3 booster tower catches. V2 is retired. The production era begins with 1 second of fire. This morning, a Soyuz rocket lifted off from Baikonur Cosmodrome carrying Progress MS-33. 2.5 tons of food, fuel, water, and oxygen for the International Space Station. That's routine. What's not routine is where it launched from. Site 31-6 is Russia's only pad that can launch crews and cargo to the ISS. Last November, during the Soyuz MS-28 crew launch, a 22-ton service cabin was ripped from its mount by exhaust pressure and fell 20 meters into the flame trench. The crew launched safely, but the pad was wrecked. Experts estimated 2 years for repairs. Roscosmos did it in 3 months. 150 workers, over 250 meters of welding. Soviet-era spare parts from the 1970s made it possible. Components built for a refurbishment that never happened, sitting in storage for 50 years, suddenly exactly what was needed. But because the universe loves drama, after launch, one of the two Kerr's automated docking antennas failed to deploy. KURS is the radar system that guides the spacecraft to the station. Without it, a cosmonaut would have to fly the cargo ship in manually using joystick controls and a live video feed. A system called Toru. The last time manual docking went wrong in 1997, a Progress crashed into the Mir space station and punctured a module. Good news. Controllers managed to work around the antenna issue, and Progress docked automatically on March 24th. But the message is clear. Russia's entire human spaceflight program runs through one launch pad, and last November, it nearly lost it. That's 6 stories tonight. A buried delta on Mars, 4 billion years old and completely invisible from orbit. 2 failed stars trying to steal enough mass to ignite. An interstellar comet carrying a chemical fingerprint from another solar system. A cotton candy planet hiding behind a wall of haze. Raptor 3, breathing fire for the first time, and a launch pad that came back from the wreckage in 3 months instead of 2 years. This is Stardrift FM. Thanks for tuning in.